Good afternoon, everyone.
Good afternoon, sir.
Okay, screen is visible.
Yes, sir.
Okay. Okay, so now in this we'll discuss the file allocation method. So in previous lecture, we have seen the directory implementation, directory structure, right? That thing we have seen in the previous lecture. Now in this lecture, we will see the file allocation methods. Okay, so why this? So the direct access nature of the disk, right? We can direct access by address. So this will allow the flexibility in implementing the files. Implementing file means we want blocks from disk. Okay, so basically there are three main category you can say, that is contiguous allocation, linked allocation, and index allocation, right? So this three implementation. So first is contiguous allocation, second is linked, or you can say, let me write non-contiguous allocation, non-contiguous allocation, and third is indexed allocation. So basically this allocation means the used block, because when you are writing something file, we are storing those blocks, right? So how we can store this block? So one is contiguous, second is non-contiguous, and third is index allocation. So in contiguous allocation method, and remember that we are allocating blocks from disk, we are allocating blocks to files, right? And each block has address, each block has address, right? So suppose if I say disk block address is 16 bits and size of disk block size is suppose 1 KB. This block address is 16 bits and this block size is 1 KB. So what is the maximum file size on disk that is possible? Maximum size of file that is possible means the maximum file size, assume that we are using all the blocks for storing data only, and that is our maximum file size, right? And here one block size is given, that is 1 KB. 1 KB, that is the size of one block, and this block address is given, that is 16 bits. All right, so 16 bits. So how many blocks? 2 raised to 16 blocks are there. Too many, 16 disk block are there. So if I consider this as a block disk, so there are 2 raised to 16 blocks are there. There are 2 raised to 16 blocks are there. Okay, and size of each block is 1 KB. So the maximum file size that is possible is 2 raised to 16 into 1 KB. Right, and this thing, if I can write, I can write like this: 2 raised to 6 into 2 raised to 10 into 1 KB. This will become, so 2 raised to 10, 1 K means that is also 2 raised to 10. So 2 raised to 10 into 2 raised to 10, that is 2 raised to 20. So 2 raised to 6 into 2 raised to 20 bytes, and this is 2 raised to 6 means 64. 2 raised to 20 means M, 1 M, and byte, so 64 MB. Right, so maximum file size that is limited to 64 MB, and we are considering all blocks for data block, right? So this way you can interpret this thing. Now let's move to this portion, contiguous allocation, right? So as name suggests, you will know what is contiguous allocation method, right? So this is my disk. This is my disk, and suppose I am writing some block. These are some blocks. Okay, and I am starting numbering from 0, 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Assume that we have 19 blocks, right? Now, when you are allocating blocks, to file, so as name suggests, contiguous allocation means it require block in continuous manner for your file, right? Suppose I have a file, name is test.c. This is my file name, right? And the starting block of this file is number 6. This is the starting block, right? And the block it occupies is 4 blocks, 6, 7, 8, and 9. These blocks are occupied by test.c. So in directory, right, we need to make the entry for this file, then and then we can know. So whenever you search your file, you should know where the data is, right? So we'll make the entry when we use this block, right? So what you will do, you will make entry in this directory table, and what entry you will make? You will make file name, then starting disk block address. What is the starting disk block address? So starting is 6, and as it is a continuous allocation, what else is required? We require how many blocks this file is using, right? So size in terms of blocks. So here right now it is using 4 blocks. Now suppose there is another file, assume prac.c. This is the file, and this file occupies this block, assume 16, 17, 18. What will be the entry? What will be the entry? In this 16, okay, and size is 3, right? So from here we could know that prac.c, what I need to do, I need to go to this address 16, and then I need to fetch 3 blocks, then I will get the content of that file, right? So if now we'll measure the performance of this allocation method, right? So first we'll see the internal fragmentation. Will it suffer from internal fragmentation? First measure is internal fragmentation. Let's suffer from internal fragmentation.
Yes, sir.
Okay, yes. How?
Sir, file
Suppose कोई
greater
फाइल
than
ऐसी कंटिन्यू
the file greater than 6 blocks would not be allocated, sir, and less than 13.
But that is internal fragmentation. What is internal fragmentation?
Sorry. In uh,
Sir,
in
there
block
won't be any
block
internal
is
fragmentation.
Yes.
सर सपोज कोई फाइल ऐसी है जिसको सिर्फ आधा ब्लॉक ही चाहिए तो फिर मतलब वो आधा ब्लॉक खाली रहेगा ना
Yes. So there is an internal fragmentation, but the internal fragmentation can be in last block, right? Is it making sense? Internal fragmentation होगा, but कब होगा? In last block. In last block, right? Suppose my size, this block size is, यहाँ पे हमने लिए 1 KB, means 1024 byte, one block size. Now assume one file size is 2050 bytes. How many blocks will be occupied by this file?
3.
3 block, right? 3 blocks will be occupied. 3 blocks of size 1024 bytes. 3 blocks are there. First block, second block, and third block. 1024, 1024, and last block, right? So 2048 occupied and remaining 2 byte. So the block size is 1024 by 24 byte each block size, right? So first one is full, second one is full, last one you can see 2 byte only. So remaining 1022, that is internal fragmentation. Internal fragmentation means wastage in block. That is internal fragmentation. Correct? So internal fragmentation is there and that is in last block. Second, what about external fragmentation?
yes, sir, possible.
Okay, how?
So earlier I said like greater than 6 and
Hmm.
less than.
Yes. So suppose this file test.c now require more blocks, that is greater than 6. 7 blocks are required. Though total 7 blocks are free, but those are not in continuous manner. Those blocks will not be allocated. Allocate नहीं होंगे. Right? So there is a external fragmentation as well. Right? So how you can see the flexibility in terms of incrementing the file size. Because we don't know the file size when we create the file, right? आप जब भी फाइल क्रिएट करते हो, डू वी नो दैट ये अभी जो मैं फाइल क्रिएट कर रहा हूँ इसकी साइज यही होगी? नो, वी डोंट नो, राइट? So what is the flexibility in terms of incrementing file size? So right now I have 2 files. Do I have flexibility? तो सपोज इसमें मुझे 2 ब्लॉक और चाहिए. सपोज prac.c इनिशियली मैंने ये लिखा है, कुछ भी अंदर लिखा है, साइज ये है. नाउ आई एम ओपनिंग दैट फाइल, राइटिंग समथिंग एल्स इन दिस. मैं और कुछ यहाँ पे लिख रहा हूँ. तो so that is not possible, right? So what I need to, in that case, I need to means plus 2 blocks are required. So I need to find out a space where these 5 blocks are free, and मुझे वो करना पड़ेगा. Okay, so I need to free this, और ये जो 5 blocks है वो यहाँ पे continuous में लेने पड़ेंगे, right? And right now it's possible, but if it is not there, then this is not flexible incrementing file size, right? And how you can access your file, right? We have seen the sequential access and random access. Okay, so your linear data structure provide that. If you see the array is provide you both the access, that is sequential and random. And if you see in array, your data is not only logically adjacent, but they are physically adjacent as well in array, right? Because row major order, column major order में आप store करोगे, तो they are in physically or logically adjacent. And sequential and random access method both are possible, but the linked list we are accessing one by one. It is sequential access. The node that we are creating using malloc and all, तो वो क्या होगा? वो कहीं भी allocate होगा. Yes, we are maintaining the pointer, so physically they are not adjacent, but yes, logically they are adjacent, because then we are accessing sequentially, right? So in this mode of access, sequential and random both are possible. Suppose I need to access the second block, so starting address I know, and then I add that address, so that is possible. I can access. Sequential I want to read, that is also possible. Okay, so this is contiguous allocation. Now we have seen some of the disadvantage, right? Like incrementing file size, then external fragmentation. So that thing we need to resolve. So the another method is non-contiguous allocation method, right? So let me erase this. Six, 7, 8, 9, 16, 17, 18, right? Okay, now in non-contiguous allocation, we will not store data in sequence. Sequence means physical sequence, right? Logically it is in sequence manner, but physically they are not in sequential, right? So how we'll store the data? Suppose there is one file, and take same example, test.c, right? So test.c, I am starting with block number 8, and after that 8 my next allocation is 13, then next allocation is 17, the next allocation is 11, the next allocation is 6. So this way I can allocate, the file. So how to maintain this is called non-continuous allocation or linked allocation, right? So how we'll maintain the entry? So one is file name, right? That is test.c. The next is starting DBA, that is 8. And what else? What do you think logically कि क्या होना चाहिए? Size of blocks, pointer for what?
Next block address.
वो तो यहाँ से मिलेगा, क्योंकि हर एक ब्लॉक अब क्या स्टोर करेगा, डेटा तो स्टोर करेगा ही, बट नेक्स्ट जो ब्लॉक है उसका एड्रेस भी स्टोर करेगा. Now this is your node of linked list. उसमें डेटा भी है और नेक्स्ट जो ब्लॉक है उसका एड्रेस भी है. सो दिस इज योर लिंक लिस्ट. ये जो है ओके, सपोज मैं ये ब्लॉक साइज कर रहा हूँ, साइज ऑफ ब्लॉक, राइट? यही एंट्री है, साइज ऑफ ब्लॉक. अब मैंने 1 2 3 4 5 है. अगर ये मैं स्टोर कर रहा हूँ साइज ऑफ ब्लॉक्स, ओके. सो अभी मीन्स कोई दिक्कत मुझे नहीं आ रही है. ओके, इंटरनल फ्रेगमेंटेशन पॉसिबल.
Yes, sir.
Internal fragmentation is possible in this case also, right? External fragmentation,
No, sir.
there will be no external fragmentation, right? Because now we are not in continuous manner. We can use any free block, कोई भी free block हम use कर सकते हैं, right? So we can use that one. Okay. Incrementing file size, it is flexible or not?
Yes.
Flexible.
Yes, that is flexible. That is flexible. Now, here you will get the answer for this. How you will increment this? Suppose ये फाइल मैंने ओपन की, I need one more block. और एक ब्लॉक कैसे अटैच करोगे? यहाँ देख के नहीं, बट लॉजिकली इम्प्लीमेंट करना हो तो आप कैसे मीन्स अटैच होगा वो ब्लॉक?
लास्ट ब्लॉक को नेक्स्ट ब्लॉक का एड्रेस प्लेस कर देंगे, जो न्यू ब्लॉक होगा वो.
क्या करेंगे हम?
एंडिंग ब्लॉक होगा, उसके अंदर जो न्यू ब्लॉक हम लेंगे उसका एड्रेस अलोकेट कर देंगे.
ओके, वो एड्रेस कैसे मिलेगा? क्योंकि मुझे यहाँ जाना पड़ेगा ना पहले. डायरेक्टली आई कैन नॉट यूज डायरेक्ट एक्सेस मेथड. लिंक लिस्ट है तो डायरेक्ट एक्सेस तो नहीं होगा, सीक्वेंशियली जाना पड़ेगा मुझे. यस.
यस.
तो अगर ये इम्प्लीमेंट हुआ तो वो कैसे होगा? डायरेक्टली यहाँ पे देख लिया मैंने कि 6 है, Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay. So wait for some time. जब तक power आ जाए. Okay, now we were discussing about non-contiguous allocation, right? So just keep that figure in your mind. कि हमने क्या किया कि कंटिन्यूअस में जो एंट्री हो रही थी वो एंट्री हम एज्यूम कर रहे हैं. फाइल नेम, starting this block address and the block size, right? So right now test.c, so starting block address था 8, तो 8 लिखा हमने. Total 5 block we are using, so we are writing that 5. Okay, now I want one more block. मैंने फाइल ओपन की, मुझे एक और ब्लॉक चाहिए. अब वो कैसे होगा? एज यू सेड कि लास्ट जो ब्लॉक है, लास्ट ब्लॉक में मुझे जस्ट पॉइंटर एडजस्ट करना है कि वो नेक्स्ट को पॉइंट करे. बट टू गो टू द लास्ट ब्लॉक में जाने के लिए क्या करना पड़ेगा? आपको लास्ट ब्लॉक डायरेक्टली मिल जाएगा.
स्टार्टिंग से ट्रेस करना पड़ेगा ना, हेड से.
ओके, स्टार्टिंग हेड से आप ट्रेस करोगे, हेड से ट्रेस करते करते लास्ट तक जाओगे, बिकॉज यू नो कितने ब्लॉक है. सो आई नो के 5 ब्लॉक है, तो हेड से स्टार्ट करके मैं लास्ट ब्लॉक तक जाऊंगा. देन व्हाट आई विल डू, आई विल ऐड दैट ब्लॉक. यस जिल?
यस सर, वो लास्ट जो नल पॉइंट कर रहा है नल को ओवरराइड कर देंगे.
ओके, नाउ आई हैव डन दिस. नाउ मैंने फाइल क्लोज कर दी. अगेन आई हैव ओपन द फाइल, फिर से मैंने उसमें कुछ लिखा एंड आई वांट वन मोर ब्लॉक. तो सेम प्रोसीजर.
सर लास्ट नोड को स्टोर कर देंगे तो बार बार रीड ना करना पड़े.
यस, so instead of blocks, what we'll store, we will store and block, because लिंक लिस्ट है. लिंक लिस्ट में एक के बाद एक आपको मिलता ही जाएगा कौन कौन सा ब्लॉक है. स्टैंडिंग, so for now we can store the starting this block address and ending this block address.
starting and ending. वॉइस
सर
बराबर
आपका
नहीं आ
वॉइस
रही है,
ब्रेक
ऐसा
हो
कुछ लग रहा है.
Yes, sir.
यस सर.
मोबाइल यूज कर रहा हूँ. अभी आ रहा है आवाज के वैसे ही. Now it's audible or
Audible, sir.
okay. So now what we'll do, we will store the starting block and ending block, क्योंकि इससे आपको लेंथ भी मिल जाएगी फाइल की जो है, राइट. So in linked allocation or non-contiguous allocation, we'll store the file name, starting disk block address and the last disk block address, right. अब एडवांटेज क्या होगा कि मुझे कोई ऐड करना है block, so I can directly go to that block, no need to traverse, because ending block address, ending disk block address हमने स्टोर किया हुआ है. ending disk block address क्या हुआ है, स्टोर किया हुआ है, right. So in our case it is 6, so we can directly go to the block number 6 and can add one more block, so that is possible. Okay, so incremental file, the flexibility in incrementing the file, right, that we'll get in this non-contiguous allocation, right. Now one more is there, index allocation. Any doubt in this?
No, sir.
So we have seen two methods, contiguous allocation and non-contiguous allocation.
Excuse me, sir. Hello, sir.
Yes.
Sir, then won't we have the same problem when we delete a sector? Delete the last
What?
sector. If I want to delete the last sector, I still have to traverse the whole system, and then I can delete the last sector.
You want to delete?
The last block. So if I want to delete the last block, I still have to traverse through each and every block and then reach to the second last block to delete the last one.
Okay, to delete the last block. You want to say that, right?
Yes, sir. So then it will be the same problem that we had during addition.
Yes. So there are certain disadvantages. This problem means this cannot be the problem, because rather than linked list, you can use doubly linked list. So in that case, this problem can be solved. But another problem is if you lost the link address, बीच में से कुछ भी गड़बड़ हो गया, तो फर्स्ट में से सेकंड ब्लॉक में गए, सेकंड ब्लॉक में से जो नेक्स्ट जाना है वो एड्रेस करप्ट हो गया क्योंकि डिस्क है, वो डेटा करप्ट हो सकता है, राइट. सो मीन्स यू कैन नॉट रिकवर होल फाइल, तो डेटा आपका चला जाएगा क्योंकि फर्स्ट टू ब्लॉक ही मिले, आगे के ब्लॉक आपको मिलने ही नहीं वाले. So that is also possible. So that's why we go for index allocation. If I give the overview of index allocation, then in index allocation, linked list में क्या था कि हम पूरी लिंक बना रहे थे कि एक के बाद नेक्स्ट कौन सा ब्लॉक यूज हो रहा है, नेक्स्ट कौन सा ब्लॉक यूज हो रहा है, likewise. But in index allocation, we'll use one block, and that block will store the address of all the blocks जो यूज कर रहे हैं. सपोज एक ब्लॉक नंबर 15 मैंने यूज किया किसके लिए, टू स्टोर द इंडेक्स. क्या स्टोर करने के लिए? इंडेक्स, और यू कैन कंसिडर एज ए डिस्क ब्लॉक एड्रेस स्टोर करने के लिए मैंने यूज किया। अब वो ब्लॉक में मैं क्या करूंगा? वो ब्लॉक में मैं जस्ट डिस्क ब्लॉक एड्रेस ही स्टोर करूंगा कि जो भी डिस्क ब्लॉक एड्रेस ये फाइल ने यूज किए वो सब मैं यूज करूंगा, वो मैं सब इसमें डालूंगा। सपोज 5 तो 5, देन 8 तो 8, ऐसे मैं सभी डिस्क ब्लॉक एड्रेस उसमें डाल दूंगा, राइट। अब मुझे क्या स्टोर करना पड़ेगा? जस्ट जो ब्लॉक स्टोर कर रहा है दैट्स इट। कंटीन्यूअस नॉन कंटीन्यूअस में कोई डाउट?
Sir, your voice was cracking earlier.
ओके, अभी मैं बंद ही करने वाला हूँ। जस्ट टेल मी एनी डाउट इफ यू हैव। Okay, so if you don't have any doubt, then you can leave the meeting. Hello.
Okay, sir.
Yes, sir.
You can leave the meeting now.